We want to solve an absolute value inequality, and I'm going to work several different examples of this type of problem of differing complexity. Okay, we want to graph the solution to the inequality on a number line, and so what I have is that x minus 8 must be less than 2 from 0. So this right here, less than or equal to. And what that means, by definition of the notation, is that negative 2 must be less than or equal to x minus 8, which is less than or equal to 2. And this is the stage where the absolute value disappears when we turn it into a compound inequality. Now, I add 8 to all three portions of this compound inequality. And this gives me that 6 is less than or equal to x is less than or equal to 10. And so my solution set, so this is where x minus 8 falls. My solution set of the final inequality is from 6 to 10 inclusive. And it's inclusive because of the equal to, less than or equal to. In interval notation, this would be the interval from 6 to 10, inclusive. For greater than, what we have is that 3x minus 3 must fall out in one of these end regions. So 3x minus 3 must be less than negative 12, or 3x minus 3 must be greater than positive 12. And then I solve each of these inequalities. 3x must be less than negative 9, adding 3 to both sides, and divide by 3, x must be less than negative 3. This is 3x must be greater than 15, where x must be greater than 5. So on the number line, I have the boundary points negative 3 and 5, open circles because I don't have equality, and it's the outer regions. So remember that greater than in absolute value will give us two outer regions, and less than will give us the single inner region. In interval notation, this is negative infinity to negative 3, not inclusive, union 5, not inclusive, to infinity. In a problem that starts out looking like this, the first thing we need to do is isolate the absolute value. So 7 times the absolute value of x plus 1, let me make my absolute values bigger so they're clear, is less than, and we subtract 9 from both sides, so that is 14. And then divide the whole thing by 7, absolute value of x plus 1 is less than 2. Or in other words, x plus 1 must fall here. So negative 2 is less than x plus 1, which is less than 2. And we subtract 1 everywhere, and we get negative 3 is less than x is less than 1. In interval notation, this is negative 3 to 1, not inclusive. Note that the difference between the graph of x and x plus 1 is just a shift of 1 unit. And then we have this problem. I'm going to subtract 2 from both sides. 4 times the absolute value of w minus 1 is greater than or equal to negative 12. Divide both sides by 4. Absolute value of w minus 1 is greater than or equal to negative 3. And we know that absolute value is always non-negative. So this is true all the time. It is always true. And so my solution set is all real numbers. On the number line, I would simply graph the whole thing. And in interval notation, it's negative infinity to infinity. In handwriting, this is the easiest way to write the answer.